Yes, hello, Funfos. Welcome back for our chemistry class. We are still dealing with the electrochemistry. This is our 9th session, and we want to look at we are still on electrochemical cells, complete electrochemical cell, and the objective today is to look at the functions of the salt bridge. That's one. 2, to define the electromotive force, and at the same time come up with what is called cell representation or cell notation. Now, so the first objective is to study the functions of the salt bridge. Now, we have 2 functions of the salt bridge. One is it completes the circuit by allowing contact between the 2 solutions. Completes the circuit by allowing the contact between the 2 solutions so that there can be flow of electric current. Otherwise, if there is a gap between the 2 solutions, electric current cannot flow. That's one. 2, it maintains balance of charges or ions on both the 2 half cells, maintaining balance of charges. It maintains balance of charges or ions on both half cells. Now, when you dissolve any ionic substance in water, for example, if we have a solution of sodium chloride, in that solution we have sodium ions and chloride ions. The number of positive charges must be equivalent to the number of negative charges. And when positive charges are equal to the negative charges, then the overall charge is 0. Meaning there is neutrality, electrical neutrality. Now, what the salt bridge does, I'm explaining the second point. What the salt bridge does is that it maintains that electrical neutrality in these 2 solutions. How? That's what we want to look at. How does it maintain electrical neutrality? So, we said that the zinc ions, the zinc atoms, ionizes to form zinc ions. So what happens to the number, because this side we have zinc, 2 ions, and we have sulfate ions. The number of positive charges the same as the number of negative charges. Electrical neutrality in this electrolyte, in this half cell. But when zinc atoms ionizes, the number of zinc ions will increase. So the number of zinc ions will increase. Increase in the number of zinc ions. Why? Because the atoms are forming positively charged ions. Will there be electrical neutrality? No, because now you have more positive charges than negative charges. Then what will happen? In this salt bridge, we have potassium ions and nitrate ions. So when the number of positive charges increases in this solution, the negative nitrate ions, will diffuse out. They will diffuse out across the cotton, the thick cotton, and move into the solution. So nitrate ions will move in. What does nitrate ions do? The nitrate ions are negatively charged, and therefore they will increase the number of negative charges, making the negative charges to be equivalent to the positive charges. So first, zinc ionizes, increasing the number of zinc ions. Then now to balance the excess zinc ions, positive ions, the nitrate ions diffuses out to balance the number of positive charges, hence maintaining electrical neutrality in this zinc half cell. What about here? Here we have said that the copper 2 ions are used up. They gain electrons to form copper. So if copper 2 ions are being used up, and we have copper 2 and sulfate ions in this solution here. You have copper 2 and sulfate ions. The number of copper 2 ions are getting used up, so their number will go down, decrease. If the number of copper 2 ions decreases, the positive charges will be less than the negative charges. There will be no electrical neutrality. So what will happen? The potassium ions in this salt bridge will diffuse out, so that as the potassium ions gets into the solution, the potassium ions will now increase the number of positive charges, and therefore it will balance the number of sulfate ions, the number of negative ions in that solution. So when the copper 2 ions decreases, the positive charges goes down, but immediately their place will be taken by the potassium ions, which will balance the charge. Now, the cotton rule ensures that there is no direct contact between the solution in the salt bridge and the solutions in the half cells. It is only the ions that are allowed to diffuse out into the half cells. In that way, the salt bridge maintains electrical neutrality. Let's move on. So let us look at what is called electromotive force, the EMF. Now, when we talk of electromotive force, it is the maximum potential difference between two electrodes of a galvanic or voltaic cell at 1 molar concentration of the ions. What we are saying, the maximum potential difference, voltage, the maximum potential voltage here, recorded here, between two electrodes of a voltaic cell or a galvanic cell or an electrochemical cell, when the concentrations are 1 molar. When this one is 1 molar and this one is also 1 molar. So what will be recorded here, the voltage recorded here, is the electromotive force of this cell. So that's what we call electromotive force, the maximum potential difference between two electrodes when the concentration of the two half cells is 1 molar, 1 molar concentration. Now, this EMF, the electromotive force, is normally represented as E cell. So when we talk of E cell, it means the electromotive force of a cell. That is the symbol. Normally, the electromotive force gives the electrode potential of the anode relative to the cathode. So whatever is recorded here is for the anode. We say this side is the anode relative to the cathode. So if we are measuring the electrode potential between two half cells, what is recorded here is for the zinc For example, relative to copper. So we say you cannot measure one half cell. You can only measure the electrode potential of the difference in the electrode potential when you combine two half cells. Now, the value that is recorded here, the EMF is the short form for electromotive force. So the EMF depends on two things. One, it depends on the position of the metal in the reactivity series. Now, it depends on the reactivity of this metal here. The position of the metal in the reactivity series. Whether the metal is highly reactive or of low reactivity. That one will affect the voltage. Another one, it also depends on the concentration of the ions